answering your questions on ultrasonics, piezoelectric devices. Let's do it. So today we're going to be talking about the question, how to measure the piezoceramics variability easily. So I want to get to the first point. And the first point is that there's so many parameters to measure. Wow. There is multiple resonant frequencies. There are lots of electromechanical property. There are different types of test setups, equipment, whether you're going to be doing mechanical measurements or purely electrical, or you're going to combine the two, or if you're doing, for example, ceramic rings are really common for obviously both clamped lines and transducers. So they're really common. So do you want to use the radial mode to characterize the disc, or the ring? Do you want to use the thickness mode because that's maybe more relevant? Or what's the sample fixture look like? There are many properties here. I'm not gonna make it simple for you. There are a lot. But actually, wait, I take that back. I'm gonna make it simple for you. How do you figure out how to focus on? How do you basically start this process? And again, why do you want to measure ceramic variability? Why do you want to measure something about the piezo ceramics? So you can ensure that your devices will be consistent with each other. That's the idea. So by measuring, you can take out the ceramics that don't fit, and secondly, you can go ahead and in some applications where you use more than one ceramic, you can actually pair them. So if you have a higher property ceramic and a lower one, you put them together, you get something in between. So you can use that to control variability and optimize performance. So we'll continue. So there's a lot of measurement frequencies, a lot of different things, properties to measure, different test setups, even including the D33 measurement of the piezo charge coefficient, which is a mechanical measurement. There's so many little things. So we're going to make it easy today, and just do your 1 kilohertz capacitance. Piezoelectric material properties. If you measure one of them, you're intrinsically, for example, I'm talking mostly about PZT. If you measure one of them, you're kind of measuring the rest of them in an indirect way. Capacitance is related to the piezo charge coefficient. You'll find that if you do tests measuring the charge coefficient for 100 ceramics, let's say via the D33 meter, and you measure the 1 kilohertz capacitance, guess which piezos are going to have a higher D33 value, the one with higher capacitance. Those aspects are related, and also they'll have a higher coupling factor for the most part. But the capacitance can be a very easily measurable, telling tool. Measuring, just keep it simple, do 1 kilohertz capacitance. You'll be able to pair devices that way, and you'll also be able to sort in this fashion. So this is really the easiest method to go if you're looking for kind of an entry-level view. You should not ever not measure anything. That's the fallacy, that we don't have an impedance analyzer, or we don't want one, or it hasn't told us much in the past. Okay, and there's so many parameters there, so it's kind of hard to tell. But if you should never settle on measuring nothing. You should at least measure your capacitance. That would help a consultant like myself who might come in to help you. You may call a ultrasonic transducer consultant like myself to help you, and I'll ask for data, and there won't be any. Let's start with capacitance. Dielectric loss is also useful, but start with capacitance. It's the hardest measurement to do incorrectly. You get an LCR meter that only measures specific frequencies. You get a sample holder almost of any type. You will be able to get reasonable values that you'll be able to do a correct measurement. 1 kilohertz capacitance. There's a little bit of, you do have to be somewhat diligent for those tests, but it's really the most forgiving test because it's sample holder independent. It's at a specific frequency. There's not a lot of settings regarding that, and it's a fairly standard test. So get yourself a LCR meter which measures your capacitance at specific frequencies. Do your measurements and record them at 1 kilohertz for your crystal and also for your assembled device as well. So because some devices have been developed for years without measurements, without detailed measurements. You simply use your final test setup to test if the device is working, your transducer is working. But when something goes wrong, you have no internal trail as to what happened, and it becomes quite challenging to recover all that going in reverse. But if you had those capacitance values, they won't take too long to measure, and it'll help someone like me or someone like yourself if you're interested in learning the subject. It'll help you and help me to diagnose that problem whenever it occurs, and it's fairly easy to do. So I hope I convinced you on measuring capacitance as a starting parameter for your ceramics. You can use it for both sorting, as a tolerance, and also for pairing high and low piezo values, and also ensuring that you're getting the same stuff every time from your manufacturer, because you may get variations, you may see performance variations, you don't know where it's from because you never did your due diligence of keeping that measurement going and logging that. All right, you've been watching your host, Dr. Shikani, answering your questions on ultrasonic transducers and piezoelectric ceramics, their applications. Check the description for notes, for the presentation notes today, also to get an idea about my consulting services and offerings if that is relevant for you. And also, there's a link to subscribe to video updates in my email. You can do this through YouTube as well, but I prefer that you do it through email, sign up for my email list, because you also get the presentation notes, which will give you a good way of kind of understanding what topics is discussed before you go ahead and go full on into the video and just lose yourself for hours scrolling through all of the shock show videos, which I know many people are doing. All right, see you next time, which may be tomorrow.